Oh, here's a couple of good dilution / understanding concentration questions. So I have a volume of 3 liters, concentration of 3.6, and that's of sodium chloride. And that's in solution A. Okay, let's draw. So here I have a solution A. It's got 3 liters, and its concentration is 3.60 molar. Then I've got another solution, 2 liters, and its concentration is 2 moles per liter. And then they say I mix them. Okay, so let's dump them all together. Now, when I dump them together, yeah, the new volume is going to be 5 liters, but the concentrations are all out because when I put this stuff in here, right now I've got 3.6 moles for every liter, but suddenly now I've got extra liters. So that concentration, these have to change. This concentration and this concentration have to change. So what I like to do is I like to determine, and they're saying, what's the concentration of silver ions? So really the only one of those that I'm interested in is the silver one. So it's the solution B. So I'm going to write silver nitrate. It'll dissociate in water to form silver ions and nitrate ions. Okay, and it says that the concentration of silver nitrate is 2 molar. So concentration is equal to moles over volume. And what I'm looking for is how much stuff, that's what moles are, how much stuff is in this new beaker. Actually, it's how much stuff is in here. Really, I'm just looking for silver, how much silver is in there. And then I'll figure out with a new volume what the concentration is. But let's first figure out how many moles of silver ions do I have. Okay, so I'm looking for N, so N is equal to C times V, and the concentration of that second one is 2 molar, so 2.00 moles per liter, times the volume is 2 liters, 2.00 liters, those cancel. Let me move these out of the way. And so the moles are equal to 4.00 moles. That's how many moles of silver nitrate I have. Now, according to my dissociation equation here, the ratio between moles of aluminum or silver nitrate and moles of silver is 1 to 1. So if this is the moles of silver nitrate, then I also have 4.00 moles of silver ions. Okay? Now, the question says, what's the concentration of those silver ions? Well, this is how many moles I have in the first solution, but when I dump that into there, it doesn't change how much silver I have. It might change its will change its concentration, but it doesn't change how much silver. All of the silver's in there. It's just that it's mixed together with a bunch of other things and a different volume. So if I want to now figure out what the concentration of the silver ions are, it'll be moles over volume. The moles are 4.00 moles. And then the volume in this container was 5 liters. You just add the two. So this would be, 5.00 liters. So if you divide that, it'll come out to 0.800 moles per liter, and that'll be the concentration of the silver ions. Do they have that? Yeah, right there. Oh, it looks like they gave the answer of 0 or a different one. Anyway, 0.800, that's what I'm getting for that one. Let's try. I have 3 liters, 3.39 sodium chloride, 2 liters, 2 silver nitrate. This time they want me to find the concentration of chloride ions. Well, the chloride ions are only found here. They're not found here. So I don't really care much about this other than it adds volume, because they're doing the same thing. So I've got A, I've got B, and then I'm dumping them into a container with C. So in this case, I'm looking for chloride ions, so I'm zeroing in on that reaction. So sodium chloride dissociates to sodium ions and chloride ions, and it's all 1-to-1. So if I figure out the concentration of sodium chloride, it'll be equal to the concentration of the sodium ions. Okay, so let's figure that out. Let's figure out the moles of chloride ions that I have in that initial thing. So concentration is equal to mole times volume. Moles is equal to C times V. The concentration is 3.39 moles per liter, and the volume is 3 liters. Okay, calculator, that's going to be what? 2, that'll be 11, carry 1, 10. 10.17 moles. That's how many moles of sodium chloride I have. Okay, so that's moles of sodium chloride. Since it's 1-to-1, both the concentration and the number of moles are 1-to-1. So this is the number of moles of sodium chloride, but because it's 1-to-1, it's also equal to the number of moles of chloride ions. And that's what we're looking for, is the concentration of chloride ions. So I have the number of moles of chloride ions, so now I can figure out its concentration. Moles over volume, moles are 10.17 moles, hope that number's right, divided by the volume. Okay, the total volume, I have 3 liters and 2 liters, so it's 5 liters. So 5.00 liters. So if you divide that, you get 2.034, I think. And that'll be moles per liter, or molar. Probably should do sig figs to 3. So it'd be 2.03 moles per liter. Now when I look up there, it looks like that's the answer that you had chosen. But they say the correct answer is 1.23. I don't see their answer. I think everything that I did was correct, so if you did the same thing, 2.03 sounds to me like the correct answer. All right, hopefully that helps.